You are preparing so well, don't worry, you can get more marks. This IIT Kanpur sample paper, it's a bit tricky and a bit lengthy as well, but don't worry, you will ace the exam very well. Okay, you will get more marks, don't get demotivated. Let's solve this question paper, let's enhance our knowledge. Okay, so let's start with the first question. The elements manganese and oxygen form a crystalline compound P. The compound is composed of cubic unit cell. Okay, that is the trick over here. Cubic unit cell, and each corner of the face centered cubic unit cell is occupied by oxide, whereas the body centered and each edge center of the cubic unit cell is occupied by manganese ion. Okay, the incorrect statement about P is, so to know, before moving to the options, I would like to derive what that molecule is. Okay, what that compound is. So for that, let's take the clue given over here. The number of oxygen atoms, how we can find that? It is a FCC, right? FCC means total how many atoms? 4 atoms, right? You already know the 8 corners are there, 1 by 8, the face, 6 face centers into 1 by 2, everything you all know already. So 4. So number of this is oxygen. And what about manganese? So it is a body center and edges are occupied, which will make once again 4 atoms. Right, 4 atoms of Mn. So the formula which will become Mn4O4, that is nothing but MnO. Right. So what is the oxidation state of Mn? That is Mn2 plus, oxide is 2 minus. Cool. Okay. So let's see the options given over here. P is a basic oxide. Yes, MnO is indeed a basic oxides. Oxides of metals are all typically a basic in nature. So which is a correct statement. Correct statement I'm mentioning. Okay. The spin only magnetic moment of manganese ion in P is 5.92. Mn2 plus, which is 3d5, 5 unpaired electrons, which makes it 5.92. I already told you the first digit of the Bohr magneton is it is a shortcut. It indicates the number of unpaired electrons, so you need not to calculate it with formula. So 5.92, that is also a correct statement. The 3d orbitals of the manganese in P split as lower energy is T2G, higher energy is EGZ. Okay, so it is an octahedral. Why that should be octahedral? Because we already know, let's say this is simple cube, and how it is occupied, above, below, and 4 on the middle, right? So which makes it octahedral. Octahedral means how it will be Eg and T2G, correct? By mentioning G also you might have known that is Eg and octahedral. So this is also correct statement. What about statement D? A sample of P has net non-zero magnetic moment at all temperature. All temperature they are mentioning. Is it true? MnO is an antiferromagnetic material. It is a paramagnetic antiferromagnetic material. At low temperatures, I mean the below Néel temperature, the spins of adjacent Mn2 plus ions aligned antiparallel to each other, resulting 0 at net magnetic moment. But not all temperature. They just have to mention below Néel temperature, which makes it this statement is a wrong statement, incorrect statement. So it becomes a right answer to this question. Moving on to the next question. Consider the following statements related to alkali metals. The crystal structure of Li2O, Na2O and K2O are anti-fluoride. Okay, so in anti-fluoride structure, the positions of cations and anions are just reversed to the fluoride one, right? So in these examples, lithium, sodium and potassium oxide, in these examples, the oxides are occupied the FCC positions where the cations will occupy the tetrahedral holes, right? Tetrahedral voids or holes, which is the correct statement. So 1 is the correct statement. What about the second one? Lithium fluoride, lithium chloride, lithium bromide are soluble in alcohol and ethers. Lithium salts have some covalent character because of high polarizing power, right? Because the lithium ion is very, very small, atomic number 3. So very small, so which makes it more of covalent character, but LiF is not significantly soluble in alcohols or ethers, right? That is an important point. You already know about that. So which makes this as a wrong statement, and the density of alkali metals from lithium to cesium increases down the group. If you find out first two, right or wrong, you can check with the option. Option B is definitely not our answer. Option B, 2 and 3, that is also not. 3 and 4, 1 is already right, so which is not our answer. What about D? 1 and 4. So let's check 4 is right or not. I'm telling you 3 as well. Option 3 mentions the density changes, right? While atomic number increases down the group, the atomic size is also increases. Okay, the density should also increase, but here in case of group 1, lithium group, there is a decrease from sodium to potassium, right? That is a difference of density happens over there. Sodium is greater, the potassium density is less. So which makes this as a wrong statement, and option D, the statement D, all 5 alkali metals from lithium to cesium can be induced to form a normal oxide, peroxide or superoxide by dissolving the metal in liquid ammonia and bubbling in appropriate amount of O2. So this is a correct statement. When an alkali metal dissolved in liquid ammonia, they form electrons, right? Electrons that can react with the different amounts of O2 to form various oxides. So which makes option D, statement D is also right. And that gives option D is right answer to this question. Moving on to the next question. Consider the isothermal reversible expansion of ideal gas and real gas from the same initial volume to final volume at the same temperature. Okay, the absolute value of work done, right? That is our question. The options are given. By the real gas is always greater than the work done of the ideal gas. Okay, so let's compare. Let's have a formula first. Okay, so what is the formula for real gas? P plus A n square by V, P minus NB is equal to RT. Okay, what about ideal gas? PV is equal to nRT. Okay, and we know that work done is directly proportional to pressure. Let's see one by one. The first condition, that is if the interparticle ion in the former is negligible. So interparticle of the ion is mentioned by A, right? So here I am taking n is equal to 1 for the simplifying purpose. So which makes it P real V minus B equal to RT, right? So P real equal to RT by V minus B. Here P ideal equal to RT by V. So tell me which is P real or P ideal, which will have more value. So obviously P real, because the denominator, see the changes in denominator. Okay, so P real is more than P ideal. So which makes work done is also real is greater than ideal. So which makes is always higher than the work done by the ideal gas. That is right. Then the real gas is always higher the work done by the ideal gas if the volume of the particle in the former is negligible. So real gas is always high if the volume of the particles in the former. So volume of the particle, here we have to consider. So once again I am taking the real gas and ideal gas equation. This time I am not going to consider about B, which is related to volume coefficient. So PV plus AV by V square equal to RT, right? Which makes PV is equal to RT minus A by V. So P is equal to RT by V minus A by V square, right? So RT by V, which can be written as P real equal to RT by V, we already know that is P ideal, right? So P ideal minus A by V square, which makes P ideal is greater value than P real, correct? P ideal minus A by V square only equal to P real, which means P ideal is greater value. So the option 2 is incorrect. And C, in both the cases will always be same since the initial and final volume in both the cases are same. So it is mentioned that initial and final volumes in both the cases are same. It's not related to volume, right? So which makes option C is wrong. The ideal gas is always higher in work done by the real gas since there is no hindrance due to interparticle interaction and the volume of the particles. That is also wrong statement. So which makes option A is right to this question. Then moving on to the next question, consider the following reactions. It is unbalanced. N oxide of the oxidation state of nitrogen follows. We are going to create a video, we are going to put a video on block elements very soon. But you have to know about the reactions as well. Okay, then only you can solve this type of question. So ammonia with oxygen 800 degrees Celsius, what that will form? So that is important. So it will form NO. And KNO3, at concentrated sulfuric acid, what that will form? With the release of H2O and R and S. Our main concern is Y only. So which is NO2. Then P4O10 plus HNO3, it is a dehydrating agent. So they eliminate the water and write it as such, which will give you N2O5, right? They are asking to arrange the oxidation state of nitrogen. So here the oxidation state is +2, oxide is 2 minus, here the oxidation state becomes +4 and here the oxidation state becomes +5. Very simple question, but you have to know the reaction, otherwise you can't answer. So Z is more, then Y, then X. So option A is the right answer to this question. Then the next one, to determine the percentage of iron in magnetite ore, a sample of ore was dissolved in acid, thus reducing the iron 2+ completely. The solution was then titrated with aqueous acidic KMnO4. The correct statement are. Okay. So this is one or more than correct answer. Okay, this is MSQ type. Multiple select answers. Let's see. So first, we have to know how the reaction happens. What are the changes? So the magnetite ore, which is nothing but Fe2O4, where that will have Fe2 plus also, Fe3 plus also, right? Okay, so they are mentioning that Fe2 plus is getting reduced. The solution was titrated against MnO4. Okay, so Fe2 plus MnO4 minus, which will give you Fe3 plus and Mn2 plus. Okay. So the first statement, the number of electrons involved in the redox reaction during titration is 5. So let's see. So the number of electrons involved. So if you are taking oxidation also, reduction also, the number of electrons should be same. So Fe Fe2 plus is oxidized to Fe3 plus, it loses 1 electron, right? And Mn7 plus is reduced to Mn3 plus, sorry 2 plus, which gains 5 electron, right? So 5 electrons are transferred overall. So which makes option A as your right answer. Not right answer, let's see. Option A is also right. Then paramagnetism of the solution increases during the reaction of Fe2 plus with KMnO4. So the paramagnetism increases. Fe2 plus, which will have 3d5 arrangement, sorry 3d6 arrangement, right? Fe2 plus, so 3d6 arrangement, and Fe3 plus will have 3d5 arrangement. So here I'm having 5 unpaired electrons, here I'm having 4 unpaired electrons, obviously, so the paramagnetism will get increased. So B is also right. Then dissolution of magnetite in sulfuric acid reduces the iron from +3 to +2. The magnetite contained a mixture of oxidation state. As I already mentioned, Fe2 plus is also there, Fe3 plus is also there. When it is dissolved in H2SO4, Fe2 plus is changed into Fe3 plus. Dissolved in acid, reducing to Fe2 plus completely. So Fe3 to 2 plus it is forming. So C is also right. What about D? During the titration, the manganese containing species changes its geometry from square planar to tetrahedral. See, MnO4 minus, which is a tetrahedral geometry. So in the option they have mentioned square planar to tetrahedral. So obviously that is not a correct statement. So A, B, C are right answer to this question. Then organic. C8H14 with HBr benzoyl peroxide forms P, and with in the presence of Q it is forming R. R is giving S, S is giving T. So let's see the options as well. They have given P, Q and T, PQT, PST and PQT. Okay. So let's solve one by one and let's see which is the right answer. Once again, this is a more than one correct. Okay, let's start from one by one. Here I am having P as Br in this position. So we don't know Q. Benzoyl peroxide is treated, which makes it anti-Markovnikov. Right? So anti-Markovnikov means the Br, the negative part, will get added to more number of hydrogens. Right? So more number of hydrogens. So there must be this type of structure. Okay, that's why the Br got added over here. So this is our C8H14. So this is forming P in the option. And at the same time, in the presence of Q, Q here is B2H6 and NaOH H2O2, which is again following anti-Markovnikov. Right? Hydroboration, anti-Markovnikov. So which will give you OH addition. Again OH this. Right? Ethyl group is there. Then it will form R. R, the reaction with chromic oxide. Chromic oxide oxidizes the alcohol to, this is a secondary alcohol, so which will form ketone. Right? Then S is formed with MgBr, methyl magnesium bromide, and then another reagent is there, 20% H3PO4. So which is a dehydrating agent. Right? Dehydrating agent to form T. So let's check whether T is right or not. So what flavonoid reagent will do? I already told you. O will become OH and methyl group will get added over there and remaining works same. And here I'm having H3PO4, which is a dehydrating agent. So if I'm removing OH from here, and the another chance would be hydrogen from here. So which makes the terminal alkene that is not stable. So that let me remove a hydrogen from this position. Okay, so hydrogen from here is removed. So which makes T as a stable compound looks like this. So option A, that works fine. Then option B. So let's start again anti-Markovnikov. So how our C8H14 will look like? So here it must be a double bond. Sorry, not here. Here must have had a double bond. So which makes P, and in the presence of Q. Q here, that is H3OH plus, which is a Markovnikov product, simply HOH addition. So which makes this OH. Then With again chromic oxide, it will form a ketone. With methyl magnesium bromide, it will form the OH part become double bond O part will become OH. Methyl group will get added and followed by dehydration, which will form this position. You can't take the hydrogens, that will form a terminal alkene. So I'm removing hydrogen from here. Okay. So which makes product like this, which is not RT. So this is not our correct answer. Moving on to option C. Option C, they didn't give Q, but they gave yes. Okay, so let's check. So let's start with the initial compound. Here I'm having Br, which makes the Br in the option A. This is our initial compound. Then it will give you P. It will undergo Q. So Q is not given over here to form to form R. So but yes is given. So R to yes is given as this type of compound. Let's check T is right or not. So yes, after that methyl magnesium bromide, which makes OH, CH3, CH3. Right. So with H3PO4, it will remove this part, hydrogen will not go. From this part, it can go to form a compound like this. Okay. So T is right. According to the given P, S and T, this is right. Okay. Moving on to D. So D, here we have bromine in different position. So let's work on it. This must be our initial product to give P and with Q. So Q is oxymercuration, demercuration. So which is again a Markovnikov product that will give you OH here. So OH will get converted to ketone, then that will form alcohol with extra Me, methyl, and then H3PO4. It will form a stable alkene, which will be like this. Okay, so D is also true, except B, A, C and D all are right answers. Okay, so moving on to the next question. The decomposition of hydrogen peroxide, which is catalyzed by iodide ion in an alkaline medium, undergoes two-step mechanism given below. Okay, so first one is slow reaction, another one is fast reaction. Cool. Here you can see iodide is not in the overall reaction, which gives us the information. Iodide is a catalyst, iodized by the iodide. Okay, happens in the alkaline medium. What we have to do? So we have to select the correct graph. Okay, so let's see one by one. The first graph mentions the initial rate versus imines. So since the rate determining step involves, that is a slow step, right, involves H2O2, the rate would be proportional to our peroxide, right? As you can see, it is proportional to our peroxide. So here I'm having I minus, it's not showing any changes. So as I minus is a catalyst, that should show any, it's not a curved one. So which makes option A is not a correct graph. Talking about option B. So the rate determining step involves I minus. So the rate would be proportional to I minus Talking about option B, here I'm having ln H2O2 of initial and final versus time. So you know that ln A0 by AT, which is equal to KT, isn't it? Just compare it with the linear equation y is equal to mx plus c. So y, that is A0 by AT, okay. So m, okay, x, this time. So which makes the linear, straight line equation. So option B is right. And talking about option C, here I'm having two type of curve. The first one is smaller than the another one, but in the reaction they have given the first one is a rate determining step, that is a slow step. So which is a where that is involved in our catalyst as well. Okay, so in that case the ideal graph should look like this, not this one. So which is not a right answer. And D, once again, if I am taking the equation, the rate, which is equal to K of H2O2, right? They have given D of H2O2 by dt equal to H2O2, that is getting decreased, that's why I put minus. So compare it with y is equal to mx plus c, you will get a graph like a straight line graph. So which makes B and D as your right answer. Then this question, in a given reaction scheme, P, Q, R are the major products. Okay, the correct statements about P, Q, R are. So let's see what is this reaction is, then we will come to the options given. Okay, so the first one, which is COCH3 with bromine NaOH. So what that will do, that will make this as oxidized one. So which will make as COOH and CH3 will be there. Okay, then that is our P, KMNO4KOH. The Q will be dicarboxylic acid. The CH3 group will become COOH. Okay, so reacting with ethylene glycol, it will give you krypton. Okay, so that is our general reaction. Fine. Let's see the options. Q is a monomer of polymer dacron. It's not a monomer of dacron. Dacron monomer will look like a para position, right? Not in the ortho one. R is a cross-linked condensation polymer. Yes, krypton is a cross-linked condensation polymer. That is true. Then C, P is more acidic than benzoic acid. Because of the ortho effect, P is more acidic than the benzoic acid. Then Q on heating in presence of P2O5 followed by the reaction with glycerol in acidic medium gives, once again the question is not fully given. Okay, acidic medium gives R. Okay, that is the question. Acidic medium gives R. Okay, Q on the presence of P2O5. In the presence of P2O5, that will lose the water content because P2O5 is a dehydrating agent which will form a benzoic anhydride. This is nothing but the phthalic acid, phthalic anhydride. This is phthalic acid, that is phthalic anhydride. Okay, then followed by the reaction with glycerol in acidic medium, that will give R. So obviously that will give R as well. It will react with glycerol. So this question is from Polymer chapter. So you have to know the reactions, then only you can answer to this type of questions. So B, C, D is the right answer to this question. Question is a numerical problem. A solution was prepared by dissolving 2 grams of non-volatile non-electrolyte solid B in 100 gram of solvent. Okay, at 354 Kelvin, the vapor pressure of the solution became exactly equal to the atmospheric pressure. Okay, so equal to the atmospheric pressure means that becomes the boiling point. If the molar mass of A is 80 gram per mole, the molar mass of B, they are asking, is the vapor pressure of A at 353 at 1 atm. Okay. So standard entropy of vaporization, which is of A, that is 85 joule per Kelvin per mole. Okay. So here these are the details we have. Let's start. Our general formula we know, that is delta TB, which is equal to KB into M, right? But to find out M, what are the needs? KB, what is M? W2 into 1000 divided by molar mass of B, I'm mentioning as M2, into W1, right? So the rest of the W1 we know 100 grams, and W2, that is 2 grams, we know. We don't know about M2, that we are going to find. So to find out that, we have to know the value of KB, right? So KB, which is equal to R into TB square into M, that is M1, by 1000 into delta H of vaporization. How do you know? How we will know delta H of vaporization? So we have a simple formula, delta S is equal to delta H by T delta S, right? So instead of T, we are using TB. So TB value from here, delta H, T delta S. So T value, that is 353, and S value is given as 85. So 353 into 85, which is 30,000. Around 30,000 you will get 30,005. Okay. So I got delta H of vaporization. So I am substituting the values. So 8.3 into TB, that is 353, M1, that is 80, molar mass of A. 80 divided by 1000 into 30,000, right? Where I'll get 2.757. So I'm substituting the value over here, 2.757 into W2. What is W2? 2 grams of non-volatile electrolyte. So 2 into 1000 divided by M2, that we are going to find, into W1, that is 100 grams of salt. Okay. So delta TB value, that is 1, correct? So I'm just have to put M2, which is equal to 2.75, 2 into 1000 divided by 100. So upon doing this, I'll get 2.75 into 20, approximately 55 point something I'll get. The answer key given as 55.26. Just check, we are getting 55.26 or nearer to that. Okay. So this is how you have to solve this type of problems. Then the next question, the aqueous solution containing copper 2 ions is treated with excess of potassium iodide to obtain the dark solution P and a white precipitate Q. The solution P turns colorless on titration with sodium thiosulfate solution. In this process, what is the number of millimoles of copper ions estimated for each millimole of sodium thiosulfate? Okay. We know excess of potassium iodide. Okay. So Cu2 plus is treated with I minus. Potassium iodide, I am taking it as I minus, which will give you dark color solution P and a white precipitate Q. Cu2, I2 and I3 it will form. So this I3 minus, the solution P turns colorless on titration with sodium thiosulfate. So I3 I am titrating it with S2O3 2 minus to produce I minus and S4O6 2 minus. So this is the reaction. Let me balance it. So I3 3 minus 2 3 and copper, that is 2. Is it balanced now? Our main concern here is that copper 2 plus and I3, because I3 is carried forward to the next step with thio. So they have given 2 copper 2 plus gives I3. So which means 2 millimole to 1 millimole. That 1 millimole plus 2 millimole of thio to produce in the titration. Okay. So the number of millimoles of copper ion estimated for each millimole of thio. So thio to copper, so 1 millimole of copper means 1 millimole of thio, which is in 2:2 ratio, so which will become 1. So answer to this question is 1. Consider the gas phase reaction. H2 plus I2 gives 2 Hi. Okay, let's take this reaction first. H2 plus I2 is in equilibrium to form 2 Hi. Great. So at the initial time, I have 4.5 into 10 to the power minus 2 moles of H2 and 2.75 into 10 to the power minus 2 moles of I2 are mixed at 700 Kelvin in a sealed vessel of 2 liter capacity. Okay. When an equilibrium is established, the concentration of Ha in the vessel found to be 2.5 into 10 to the power minus 2. Okay. So at equilibrium, so I have to minus 2.5 from the initial amount of H2, isn't it? So which will become 2 into 10 to the power minus 2 after subtracting, and here that will become 0.25 into 10 to the power minus 2 and into 2, correct, 2 Hi I have. So into 2, total it will become 5. 5 into 10 to the power minus 2. Cool. So this is what the details I have. Other than that, we have to find the standard Gibbs energy of this reaction. Delta G I have to find. Okay. So for that, I'm going to use Kc, which is equal to square H2 concentration, I2 concentration. I'm going to substitute the values over here. 5 into 10 to the power minus 2 square into 2 into 10 to the power 2 minus 2, 0.5 or 25, 0.25, 0.25 into 10 to the power minus 2, isn't it? So upon doing the calculation, I'll be ended up with 50. So Kc value is 50. So delta G, which is equal to minus RT ln Kc, R value that is given as 8.3. Cool. So 8.3 into temperature 700 Kelvin, Kc value 50. So I'm getting ln 50, I can write, okay, ln 50 this is. Cool. So upon solving this, I'm ended up with 22.74. Okay. So 21 to 24 is the range. This is the answer to this question. They are asking for in the modulus only, so need not to worry about the sign. So 22.74 is your answer. 5. So by solving this, 5 log 2 will become 0.3. So 5 minus 0.3, that is 4.7. So 4.7, here they are mentioning it as n into 10 to the power minus 1. So 47 into 10 to the power minus 1. So 47 is your answer. Okay, cool. So these are the questions which are there in the sample paper. So we'll create more videos on block chemistry, and what else videos you want for the concept clarification on the questions, let me know in the comments. Keep practicing more and more questions. Keep motivated. Thank you.